Okay, so we have to find the magnitude and direction of the magnetic field at point P. Let's get the direction of the two magnetic fields first, and then I think this will be pretty straightforward. So this is a right triangle. I'm going to go ahead and complete the triangle here by drawing a line. This will have a distance R2, and R2 can be found from the Pythagorean theorem. 0.15 squared plus 0.24 squared, and that's 0.283 meters. And then this angle theta is inverse tangent of opposite over adjacent, which is 32 degrees. Okay, so we'll start there. Now, the right-hand rule for current I1 tells us that the current is going around I1 like that. Okay, and so at this location P, it is going to be perpendicular to the line that connects. Right, it's going to be perpendicular to this line, and it's going to point to the right. So there's B1, points in the positive x direction. So that's easy enough. I2 is going to be a little trickier. Now I2, according to the right-hand rule, curls around, the magnetic field due to I2 curls around like that. So what I need to do then is I need to draw a line perpendicular. Right, this is a line that's perpendicular to this radius vector. Right? And since the magnetic field goes around like that, then that means the magnetic field due to I2 is going to go off like this. Okay, now as far as angles are concerned, let's see. Well, this angle is 32 degrees. This angle here is 90 degrees. And so that means this angle must be 58 degrees. Right? I mean, if you wanted to, I guess we could continue on with this line and say that that's 32 and that these two angles have to be at right angles. So however you want to slice it, the magnetic field B2 points off in a direction 58 degrees below minus x. Okay, so now we just need to find the magnitudes of these two things. So B1 has a magnitude of mu naught I1 over 2 pi R1, and that's mu naught times 5 over 2 pi times 0.15. So that's 6.67 microtesla, and that's in the plus x direction. And then the magnetic field B2 is, let's see, so I2 is 8 amps. And we divide by 2 pi times 0.283. And that is 5.65 microtesla in a direction 58 degrees below minus x. Okay, so now I've got magnitude and direction for two vectors. I just got to add them up. And so the way we do that is we break it into components. The x component of B1 is plus 6.67. The y component of B1 is 0. The x component of B2 is minus 5.65 cosine 58, which is minus 3. And the y component of B2 is minus 5.65 sine 58, which is minus 4.79. Okay, so I want to add up the components. The total x component is plus 3.67, and the total y component is minus 4.79. Now I've got to reconstruct my resultant, so I'm going to make a little coordinate system here, and I'm going to go over plus 3.67 in the positive x direction, and then 4.79 in the negative y direction. And so this is going to be my total magnetic field, making some angle alpha with the minus x, or with the plus x axis. The magnitude of B total, it comes from Pythagorean theorem, right? 3.67 squared plus 4.79 squared gives us 6.0 microtesla. And then the angle theta is inverse tangent of opposite over adjacent. Now, you know by now, by seeing enough of these, that I never put a negative sign inside the tangent, right? I don't make this negative 4.79. I don't put a negative there. I always make that positive because I've already decided that the direction is below minus x. I don't need to confuse my calculator by putting a negative argument into the tangent. So it gives me an angle of 53 degrees below plus x. So there's our magnitude and direction, and we're done.